Hello, everybody, and welcome back to week 10 of Environmental Concerns. I'm Michael Clare, and this week we're going to be talking about renewable and non-renewable sources of energy. We'll be discussing their pros and cons, and just generally the different options available to us in the present. So first off, I'm going to start off with just the non-renewables, because they're, what we're pretty familiar with for the most part. There's your oil, your coal, your natural gas, and your nuclear energy. So as the name suggests, non-renewable energy is a source of energy that will eventually run out. The source of what creates the energy or what's used to create the energy will eventually run out. Fossil fuels are a good example of that. All energy sources have their pros and cons, and each must be weighed carefully to determine the proper course of action of what we should be using. So these are the laws of thermodynamics. The only important one in terms of what we're going to be kind of going over with the different energy sources or different ways of collecting power is the first one here. The energy can neither be created or destroyed. It can only be transferred from one form to another. So here we go. We got coal, the first one we're going to be discussing. So as it says there, coal is formed when dead plant matter decays into peat, which is then exposed to extreme heat and pressure of deep burial over millions of years. Coal power plants were first built and they were first used in the late 19th century. The way that coal works is it converts thermal energy to mechanical energy and then finally into electrical energy. So the way that this works is the coal is pulverized and burned. Sorry, I got something in my throat here. The heat from the burning coal converts boiler water into steam, which then rises as steam does, and it spins turbines. And these turbines continue spinning and turning, which turns generators, which creates your power. So it goes from thermal energy, as I said, to mechanical, and then finally into electrical. So these are just showing like electricity production from coal as of 2021. So as you'll see, which is kind of interesting, some of the Middle Eastern areas, China, well, not Middle Eastern, sorry, the Eastern Asia, so like China, India, even Australia to an extent, are very heavy users of coal. Coal is actually currently powering 40% of the world's power, so it's probably most likely the majority of what creates electricity for us. But what's interesting looking at this chart is just how much China depends on it. So as you can see, the leading countries by coal consumption worldwide in 2020, China uses 82.27 exajoules. So just to give you an example, 1 exajoule is 1 quintillion joules, which probably doesn't mean a whole lot to you, but to put it into a sort of basis that you might understand, the yearly U.S. energy consumption is roughly 94 exajoules. So if you're looking at this, China produces 82 in just coal alone, not even looking at nuclear, not looking at oil, not looking at wind power, solar, whatever it may be. They use 82 exajoules per year in just coal, which is staggeringly high. So it is, as I said, the world's leading source of energy-related carbon pollution because it's used so predominantly as like the major source of energy in many countries. So the question becomes, when will countries phase out coal power? Because there's benefits and negatives, right? As I said, there's pros and cons to every energy source. Coal does provide a lot of good bang for its buck, but obviously it produces a lot of pollution as a result. So as you can see from this chart, there are quite a few countries, including the United States, which is interesting, saying that they have no pledge to eliminate coal from their electricity mix. But as you can see, Canada, they want to phase it out by 2030. A lot of Africa is already not using coal, which might be a factor due to the cost to create these power plants, but also they just get their power from other sources. And Europe also has, it looks, a majority of it being phased out by 2030 or 2040. Or they're just coal-free already. Natural gas is the next one we're going to be discussing. So natural gas in a nutshell is those naturally occurring hydrocarbon gases that consist of methane and various other alkanes. Alkanes are just groups of carbon with hydrogen attached to it. So colorless and odorless. So a sulfur smell is added for early detection of leaks. Otherwise, you would have no idea natural gas was actually leaking if there was not that sulfur smell added to it. It is a potent greenhouse gas, though, when it's released into the atmosphere, and it does also create carbon dioxide when it's burned. So although technically natural gas is cleaner than coal, meaning that for the same amount of natural gas that's consumed for power, you produce less carbon dioxide than coal would, it's unintentionally dirtier, since natural gas itself is a greenhouse gas as well as the burned off carbon dioxide. So any leaks can also have the unintended cost of further damage to the environment. If you dump coal, for instance, it's not going to, you want to clean it up, but it's not going to impact the atmosphere like spreading natural gas would. So this is looking at gas consumption as well as gas production. So although natural gas is used as a power source for electricity generation, it's probably not also surprising to learn that a large number of the countries, and I'm going to move my mouse over here, that are at the top of natural gas consumption are the colder ones. This is because they don't only use natural gas for electricity generation, but they also use it as a source of energy for heating and cooking. You're probably familiar with natural gas being used for heating purposes. Interestingly, the United States and Russia are also the ones that produce the most natural gas. It's now actually considered the second largest source of electricity globally, with, of course, coal being number one. Many countries actually do substitute natural gas for coal, which is a positive direction for the environment since, as I said earlier, natural gas does emit less CO2 than coal, but it's still a pollutant. Still, we still would want to move towards nuclear or other renewable sources of energy. So the next one we're going to discuss is oil. So oil, everybody's probably very, very, very familiar with, considering the times we're living in too. But it's a fossil fuel created from the remains of animals and plants that have had extreme heat and pressure exerted on them due to being covered by layers of sand, silt, and rock. You'll notice it's quite similar in how coal is created as well. Crude oil is refined into many products that we use. There's gasoline, there's diesel fuel, heating oil, jet fuel, petrochemical feedstocks, waxes, lubricating oils, asphalt, and even plastics themselves are all made or use a component of oil to be made. When you're looking at this chart here and it's showing the kind of breakdown of a barrel of crude oil, gasoline is pretty evident, but distillate here is actually referring to both diesel fuel and heating oil. So as I mentioned, oil is kind of an important part of our life. It's such a very contentious subject and something that countries vie over. I mean, this is just a news article I grabbed off of Google like the other day. You could probably literally Google oil. And this is the funny part. If you Google the word oil, how long do you actually have to scroll before you just find a website that it just explains or describes what oil even is? Normally, when you just pop a word into Google, one of the first hits is usually just going to be describing or explaining what that word actually means, right? Oil, you have to travel quite a bit just to find what you're actually talking about there. So oil prices do effectively rule our world when you think about it. Think about how much everything costs lately, right? This is partly still due to the pandemic. There are harbors still to this day that have ships that are waiting to unload their cargo. However, high gasoline prices are affecting transportation heavily. This is one of the things that is driving the cost of living up huge, because even if you get the stuff off of the cargo ship, for instance, it still needs to make its way to a grocery store. It still needs to make its way to manufacturing plants. It needs to make its way to just production facilities, what have you, right? So all that transportation cost and the higher gas prices are really jacking everything up, which is sucky for us, to say the least. But as a power plant, oil power plants are similar in function to natural gas or even coal. It's the same kind of process, just different materials being input in the start. So as I said before with coal, I'm going to say it again with oil. Basically, oil is burned, and the heat that is caused from this burning turns water into steam, which rotates a turbine, which turns a generator. So another method is actually through the internal combustion engine, which works by converting the explosive potential of oil directly into mechanical energy, which runs a generator. You guys are probably familiar with combustion engines because that's what our cars use, unless you're using an electric car, which is a whole other thing. So I'm going to show this quick video which shows how a combustion engine works.
A car engine generates power from the expansion of compressed air in a contained cylinder with the help of fuel. That is why it's called as an internal combustion engine. Before getting into the working, let's see the main parts involved in the working of an engine. First, the crankshaft. This is the part which converts the linear motion of the piston to a rotational force. Next, the pistons and the piston rods. The pistons will be pushed down by the expansion of compressed air, and turns the crankshaft. And the valves, which controls the flow of air and fuel into the cylinders. These valves are driven by the intake camshaft, and the exhaust camshaft, and the camshafts are driven by the crank itself, using a timing belt. There will be idler pulleys, and a tensioner pulley, to hold the belt tight in place. This here is the internal structure of a 4-stroke, inline 4-cylinder, DOHC engine, which is commonly found in most hatchback and sedan cars. A 4-stroke engine should pass through 4 different strokes to complete one cycle to produce power. They are intake, compression, power, and exhaust stroke. The crank to camshaft ratio is 2:1, which means it will take 2 crank revolutions to complete one camshaft revolution. And the camshafts are designed in a responsive manner to open or close based on the corresponding strokes of each cylinder. Let's take a look at a single cylinder and see how a 4-stroke engine works in detail. In order to ignite the air-fuel mixture, a spark plug is used. This will ignite the compressed air-fuel mixture with the help of an electrical spark. We will take it down by each stroke. The intake stroke. The inlet valve opens and the downward movement of the piston creates a suction. This pulls the air-fuel mixture into the cylinder. Once the air-fuel mixture is in the cylinder, compression stroke begins compressing the mixture. At this time both inlet and outlet valves stays closed. At the end of compression stroke, the air-fuel mixture is ignited by the spark plug. The explosion exerts pressure and pushes the piston down. This is the power stroke which produces power to the crank. At the exhaust stroke, the outlet valves opens and the piston pushes out the burned gas. The cycle starts again from intake stroke, keeping the engine running and produces power. For a carburetor engine, the air and fuel are mixed inside the carburetor assembly, and fed to the cylinders. In the case of a fuel-injected engine, the fuel is injected into the intake manifold, or directly into the cylinders. Since only a power stroke produces power, you may wonder how the engine turns continuously. Well, the answer is in the crank itself. The flywheel and the crank counterweights provides momentum, which keeps the crankshaft from stopping immediately. For a 4-cylinder engine, considering any time instance, one cylinder is always in power stroke, which produces more power and less vibrations comparing to a single-cylinder engine. And that is how a car engine produces power in simple. Thanks for watching, and stay tuned for more presentations from Autotech Labs.
I do enjoy when it's that like automated voice. It sounds kind of awkward. Oh, let me out of here. Okay, so the last part with oil that we're going to look at is just the producers and the imports of gold that happen. So interestingly, the biggest producer of oil in the world is actually the United States. If you didn't know that, you might have thought it might have been Saudi Arabia or even Russia or even us to an extent. But I mean, that's basically your top 4 right there, right? What's funny too is we actually have a very close relationship with the States in terms of oil trade. So as you can see in the pie chart on the left, of all the imported oil that the US gets, over 50% of it actually comes from Canada. The next one we're going to discuss is nuclear power. So nuclear power is clean in terms of environmental concerns in a theoretical model where things don't blow up or go wrong. And it's an efficient way of boiling water to make steam, which turns the turbines to produce electricity. So again, it's a very similar process where you're boiling water to produce steam, which turns turbines, which turns generators, which produces electricity. The difference is what you're actually using to create that electricity, your first product or your first material that you input. So in this case, you're using uranium or plutonium fuel through a process called fission. When a neutron slams into a larger atom, the larger atom is split into smaller atoms, and this is fission. This releases additional neutrons, which can then also cause a chain reaction. So when an atom splits, a tremendous amount of energy is released. This is the whole idea of, you split the atom and you create the nuclear explosion. Interestingly, about 15% of Canada's electricity to date comes from nuclear power. Ontario alone is pretty much the only place that has nuclear power plants. As you can see, we have 19 total. I kind of screwed up the wording on that, but it's supposed to be Canada currently has 19 reactors, 18 in Ontario and 1 in New Brunswick. I'll have that fixed up for when I upload the PowerPoint for you guys on Blackboard. About 10% of the world's electricity comes from about 440 power reactors that are nuclear. It's the second largest source of low carbon power, and over 50 countries use nuclear energy. You can see here 30.9% of the United States, 3.6% Canada, 13.3% France. This is just how much of the world's nuclear energy, how much of the world's or the country's different electrical needs are met by nuclear. There is future tech kind of theoretically being produced called fusion, and this is just explaining quickly what the difference is between fission and fusion. It's still a theoretical energy source, so it's not something that can be used yet, but it has a potential to be a clean energy source that we could use. So whereas fission is splitting a larger atom into 2 or more smaller ones, fusion is the act of joining 2 or more lighter atoms into a larger one. So whereas nuclear power would use uranium as plutonium as its fuel types, as I said, fusion actually uses hydrogen. And if you're familiar with your periodic table, hydrogen is actually only a single atom. It's just 1 proton, 1 neutron, 1 electron. The byproducts of fission is your used nuclear fuel, radioactive. Your used fusion byproduct is helium, which is what you get. It's literally the second element, right? It's 2 hydrogen being combined together to produce helium. So as you can see in that last little part, nuclear energy is currently in production, like they use it, whereas this is just, under development, it's being theorized. I'm going to take me off for just a quick second, just so you can see the last bit, where nuclear does produce quite a bit of energy, as it's showing here, 1 million times greater than other energy sources. But fusion is even greater than that. It's 3 to 4 times greater than even fission. So if this is 1 million times, this is 3 to 4 million times greater. So it's an interesting. I'm not going to talk about fusion any more than I just did. It's just an interesting food for thought thing to talk about. So I'd be remiss not to talk about the Chernobyl disaster that happened when we're talking about nuclear power plants, because that's probably one of the first things people think about when they think about nuclear. So in a nutshell, it's kind of, it's kind of relevant considering the world politics of the moment too. This is a power plant, Chernobyl disaster, that was located in Chernobyl, Ukraine, which was part of the Soviet Union at that time. And on April 26, 1984, an accident occurred during a safety test on the steam turbine. I'm just going to go through the wording really quickly about this, and then there's a video afterwards that kind of elucidates a little more information for you. So the power output had dropped to near zero during a planned decrease of reactor power, and the operators were just unable to restore that power level specified by the test program, which put the reactor in an unstable condition. This risk was not made clear in the instructions, so the operators just continued with the test, not really knowing any better. and upon test completion, the operators triggered a reactor shutdown. The combination of their negligence and just some design flaws in general had made the reactor primed to explode, so instead of shutting down, a nuclear chain reaction began and it released enormous amounts of energy. The core melted down and 2 more explosions destroyed the reactor core and the building. There was a lot of airborne radioactive contamination that was released for 9 days that spread to other parts of the USSR and Europe itself. The explosion itself, just alone, killed 2 engineers and severely burned 2 more. The immediate emergency response had 134 staff hospitalized with acute radiation syndrome. And of those 134, 28 died within days to months, while 14 more died within 10 years due to radiation-induced cancers. And here's a little video. I'll get me off the screen first for this.
More than 30 years on from the disaster that made its name infamous, the Chernobyl nuclear power plant still holds an uneasy fascination for many. The events of April 1986 have recently been dramatized in a HBO series. But what really happened? And why did it send shockwaves throughout the world? The Soviet Union invested heavily in nuclear power after World War II, and the V.I. Lenin nuclear power station, 10 miles to the north of Chernobyl, had become operational in 1977. There were 4 RBMK nuclear reactors at the site, each capable of producing 1,000 megawatts of electric power. On the night of the 25th of April 1986, sleep-deprived plant workers ran a series of tests on Reactor 4 during a period of routine maintenance. They wanted to see whether the reactor could still be cooled if the plant lost power. But they violated safety protocols and several power surges occurred inside the reactor. It led to a chain reaction of explosions powerful enough to blow off the steel and concrete lid. With the reactor's core exposed, radioactive material spewed into the atmosphere. Official reports claimed that 2 plant workers died in the initial explosion, but some estimates put the number closer to 50. Dozens of firefighters called in to extinguish the flames were also hospitalized with radiation sickness. With the Cold War still going on, the Soviet Union did all it could to avoid the disaster gaining international attention. It was 36 hours until orders were issued for the neighbouring town of Pripyat, built for plant workers in 1970, to be evacuated. By the time airborne radioactivity was being picked up at Swedish monitoring stations, the Soviets could no longer sustain secrecy around the event. They made a brief announcement on April the 28th, and an outcry over the dangers posed by radioactive emissions began in many Western European countries. To contain the fire blazing in the exposed core, sand, boron, clay and lead were dropped onto the flames. The Soviets then tried clearing debris with remote-controlled robots, but when the machines started breaking down in the toxic atmosphere, groups of men were brought in to clear 100 tons of radioactive material from the area. Later in the year, the first steel sarcophagus was built to contain the plant's 4th reactor. Despite being structurally unsound, it would remain in place until 2016, when a new container was built. Even with this protection, it's estimated the zone around the reactor itself will not be habitable for another 20,000 years. The Soviet Union eventually established a 19-mile-wide exclusion zone around the reactor, uprooting some 335,000 people. Nevertheless, a UN report asserted that more than 6,000 children and adolescents developed thyroid cancer as a direct result of the incident. Hundreds of thousands of people may ultimately have been affected. On top of this, it's estimated the disaster cost some $235 billion in damages. It contaminated almost 1/4 of agricultural land in modern Belarus and hastened the collapse of the Soviet Union. Other than a few scientists and tourists intrigued by Chernobyl's history, the zone around the power plant is now eerily quiet and remains off limits to anyone without a permit. Even today, the full scale of the disaster isn't fully understood and remains an area of active research.
Interesting stuff. That's basically it for the non-renewables. I'm going to focus a lot more on the renewable energies, hence this is an environmental concerns course. So it's more interesting to talk about the renewable energy sources because it's looking forward to what we could potentially use. So focusing on renewable energy sources other than fossil fuels and coals might help in avoiding environmental impacts, specifically from air pollution and greenhouse gases. Nevertheless, all forms of electricity generation have their impacts. So to achieve a low carbon future, we need to understand the effects of different renewable energy resources. You're probably going to be surprised to learn that some of these renewable energy sources, they do have a bit of a con side, I guess we'll say, or some detracting stuff that's not going to make them as appealing as you might have thought initially. So renewable energy is derived from natural sources that are continuously and sustainably replenished. Renewable energy comes from wind energy, from solar energy, biomass energy, biogas energy, geothermal energy, hydropower, and offshore wind, wave, and tidal energy. At the end of the day, if we're excluding like the biomass energy and biogas energy, basically everything energy can come from for renewable sources is going to come from either the sun, it's going to come from the moon, or it's going to come from the earth. So the materials used in creating renewable energy installations, they include these elements. And these are actually considered like rare metals. You got neodymium, you got dysprosium, cadmium, tellurium, gallium, indium, and then selenium. These materials have been used only recently, which means that there are limited or no recycling systems yet. A solution to facilitate the large-scale recycling of these materials needs to be designed to avoid problems in the future. These systems are so new that there are not currently enough renewable power plants to be retired that could be studied to address this issue. So to use as an example, a wind turbine may have a lifespan of 20 to 25 years, meaning that the material investments may last for 20 to 25 years before they need to be replaced. If you look at that in another context, where at those previous metals that I was talking about, like your neodymium for instance, if it also has a lifespan of 20 to 25 years, if we only started using them 5 years ago, they still got another 20-ish years to go, so we have no idea how the recycling process works with them necessarily yet. In the end, a long-term plan must be established to recycle the current renewable energy systems, or we merely just create a problem for future generations. Because then it's just sitting around, it's not recycled, it's just wasting away once its like end of life has been reached. So these are the main methods of renewable energy that we're going to be discussing today. You got solar, you got wind, wave, tidal, geothermal, hydroelectric, biomass, and biogas. So let's start off with the most popular of those, the solar panel, something that probably everybody here is familiar with, probably seen too. Many solar farms can be found in our area, spanning across acres and acres and acres of land. You've probably seen them on rooftops of people's buildings too. There are two categories of technologies that harness solar energy, and we're going to be discussing both of them. You have your solar photovoltaic, and you have your solar thermal. So solar power has an environmental impact that depends on where the installation is located. For instance, a tropical hydropower installation that is big and shallow can actually result in greenhouse gas emissions when it swamps and kills vegetation. Carbon dioxide is released in such instances, as well as methane, a greenhouse gas that is about 30 times more powerful than CO2 at trapping heat within the atmosphere. Methane is also the gas that you guys are probably familiar with as flatulence, farts. So first off, we're going to talk about the photovoltaic. So solar is a renewable energy source. It does not emit any greenhouse gases in the energy generation process. However, the cost of solar in relation to other fuel sources is a barrier to adoption. Additionally, sunlight does vary depending on geographic location, their season, and the time of day, which all creates limitations on its use. It is more efficient closer to the equator than northern regions which have reduced winter sunlight. So as an extreme example, just to kind of paint a picture, the Arctic has a sunlight all day long in the summer. However, in the autumn, it's basically in perpetual twilight, and after October, it's in full darkness for the entire winter. Clearly, solar panels might be effective during the summer here, but during the winter, during even the fall and the spring, not so much. The potential of solar energy is actually beyond imagination, though. The surface of the Earth receives 120,000 terawatts of solar radiation and sunlight, which is 20,000 times more power than what is needed to supply the entire world. An abundant and renewable energy source is also sustainable. So sustainable energy sources meet the needs of the present without compromising the ability of future generations to meet their needs. In other words, solar energy is sustainable because there's no way we can overconsume. There's no scenario where the usage of solar panels actually quickens the lifespan of the sun. We've got this sun for a couple billion years, knock on wood in case something happens. So there's no risk of overconsuming solar energy. There isn't an allotment of sunlight per day we get that solar panels will be taking from. So harnessing solar energy generally does not cause pollution. However, there are emissions associated with the manufacturing, the transportation, and the installation of solar power systems. Almost nothing compared to most conventional energy sources like oil or coal power plants, but it's still something to consider. It's clear that solar energy reduces our dependence on non-renewable energy resources. It's an important step in fighting the climate crisis. Solar energy is available all over the world. Even though places like the Arctic, as I said, are not ideal, there's still sun basically everywhere throughout the world. So not only the countries that are closest to the equator, where it would be best, can put solar energy to use, but Germany, for example, has by far the highest capacity of solar power in the world. They have the most solar panels set up. 10 years ago, in 2009, the cost of a solar panel installation was $8.50 per watt. The solar industry today looks very different. In addition to solar panel efficiency increasing dramatically, producers have significantly improved their manufacturing processes. Installers, too, can deploy solar photovoltaic across the United States more efficiently now than they could 10 years ago. So as a result, which would make sense to you, the price of solar has fallen by over 60% to just $3.05 per watt. The important thing to remember is that solar panels basically need to point where they have the best chance of collecting sunlight. So for those of us in the northern hemisphere, which is, I'm assuming, most if not all of us, we point our panels to the south. This gives us the best chance of receiving sunlight all day. If you're in the southern hemisphere, you'll want to point your solar panels north. So it wasn't until 1954 that Bell Labs invented the first useful silicone solar panel, which was about 6% efficient. Since then, solar photovoltaic technology has evolved at a rapid pace. Manufacturers have been able to create solar panels that are nearly 30% efficient. In fact, there's even new technology that's developed panels that are about 45% efficient, but currently they're just not cost effective, because the materials that they're made of are just too expensive. So what does it mean to be 30%, 45%, 6% efficient? It's the conversion of the sunlight to usable energy. Remember that first law of thermodynamics I was discussing. Typically, the energy that is captured, or that isn't captured rather, is released as heat. So we capture 45% in that best case scenario, and we are able to utilize that as electricity, but then the other 55% of it is actually just lost as heat. And when I say lost, I just mean it's transformed into another form. You don't lose the energy. As I said, energy cannot be lost or gained. It's constant. It just transforms into another form that we just aren't able to use for electricity. So a couple benefits to solar panels is their silent operation. There's no moving parts to them, since it's just a solar panel sitting on your roof, for instance, in this picture. There's no noise associated with photovoltaics. This compares favorably to certain other green techs, such as wind turbines, which do make noise. The building materials. With the introduction of flexible thin film solar cells, solar power can even be seemingly integrated into the material of buildings. Building integrated photovoltaics. Sharp is a solar panel manufacturer with a headquarters in Japan, which actually recently introduced transparent solar power windows, which is kind of a cool idea. With the introduction of net metering and feed-in tariff schemes, Homeowners can now actually sell their excess electricity or receive bill credits during times when they produce more electricity than what they actually consume. So although solar panels may be a big investment in the beginning, over time they may actually start paying for themselves, which is another incentive for, everybody to rent out and start throwing them on their roofs if you're able to. So this is the thermal one. If anybody's watched, James Bond movies, or probably quite a few action movies, for instance, this is probably, like, especially that bottom picture, looks probably pretty familiar to you. Solar thermal power generation systems work a little differently. The thermal's probably the part that it will tip you off on how their point is overall. What they do is they concentrate sunlight to produce the high temperature heat needed to generate electricity. So as you can see, it's basically surrounded by a field of mirrors, and then you have your solar receiver up here. So how it works is basically all the reflectors, your mirrors, capture and focus sunlight onto a receiver. So this just basically starts boiling up as all that heat and all that sunlight is redirected from the mirrors onto the receiver. In most types of systems, a heat transfer fluid is heated and circulated in the receiver and used to produce steam. Again, probably sounds familiar to your other types of energy sources, right? The steam is converted into mechanical energy in a turbine, which powers a generator to produce electricity. Sounds familiar, right? Solar thermal power systems have tracking systems that keep sunlight focused onto the receiver throughout the day as the sun changes position in the sky. Wouldn't do if you had the mirrors kind of statically located in place, and then the sun moved and the mirrors weren't just collecting the sunlight anymore, right? So they kind of move or orientate a little bit as the sun moves to make sure that sun's redirected to its the receiver. So solar thermal power systems may also have a thermal energy storage system component that allows the solar collector system to heat an energy storage system during the day, and the heat from the storage system is used to produce electricity in the evening or during cloudy weather. You would hope that technology had improved a little bit, but cloudy weather will still impact how much energy or how much sunlight these solar panels can collect. Makes sense, right? The cloud is actually blocking some of the solar radiation from reaching down. Just like when it's a cloudy day out, it seems a little darker out. It's the same idea. Solar thermal power plants may also be hybrid systems that use other fuels, usually it's natural gas, to supplement energy from the sun during periods of low solar radiation. It's not an ideal situation, but if you have this solar power plant and its purpose is to provide power for, a small neighborhood, a small town, whatever, it wouldn't do that, the sun's not out today and everybody loses power. You have to have some sort of backup plan for that. And at the moment, it's usually natural gas. There are disadvantages, though. As I said, I'm going to talk about pros and cons for all of these renewable sources. If we want to backtrack to the non-renewables, one of their advantages is that the bang for your buck is usually pretty extraordinary, considering how much energy you can get from oil and coal and gas. But with solar power is the disadvantage. The cost of solar in relation to other fuel sources is a barrier to adoption. Additionally, sunlight varies depending on geographic location, season, and time of day, which all creates limitations on its use. Again, looking at that Arctic situation as an example. Although pollution related to solar energy systems is far less compared to other sources of energy, solar energy can still be associated with pollution, so it's not completely carbon-free from entire lifespan. So like from concept to beginning to actual production and then use of it. It's the production where a lot of it, in the transportation and installation, have been associated with the emission of greenhouse gases. There are also some toxic materials and hazardous products used during the manufacturing process of solar photovoltaics, which can indirectly affect the environment. Nevertheless, solar energy itself pollutes far less than other alternative energy sources, and as yet, no recycling methods to the panels once their effectiveness has depleted. So we have no way of recycling or reusing those panels, which is also a problem because then you start filling up landfills or something, which is also not great for the environment either, right? Photovoltaic modules typically come with a 20-year warranty that guarantees that the panels will produce at least 80% of the rated power after 20 years of use. A general rule of thumb is that the panels will degrade by about 1% each year. Wind energy is the next one we're going to discuss. It's a contentious subject sometimes. So wind energy is a green energy source. Harnesses wind energy, does not pollute the environment nearly as much as fossil fuels, coal, and nuclear power does. It's true that the manufacturing, transportation, and installation contributes to global warming slightly, just like solar panels would, but the electricity production itself does not involve any emissions of climate gases whatsoever, because it's just the wind itself that's being collected. So the worldwide potential of wind power is more than 400 terawatts. Wind is naturally occurring, and there's no way we can empty the energy resources. Wind is caused by the uneven heating of the Earth's surface by the sun, in a nutshell. So this is due to the Earth's surface just being made up of different types of land and water, and they heat up differently. As long as we have the sun heating up our Earth, which, I mean, come on, we will have wind. The largest wind turbines are capable of generating enough electricity to meet the energy demand of 600 average United States homes. The wind turbines can't be placed too close to each other. I mean, they'll knock into each other or something like that, or they'll just interfere with each other's ability to collect wind, but the land in between can be used for other things. This is why farms would benefit more from installing wind turbines as opposed to solar panels. Solar panels, they kind of take up the whole space, right? The wind turbines are big, but they're way up high where your crops aren't going to care. So although wind power only accounts for about 2.5% of total worldwide electricity production, the capacity is growing at an incredible rate of 25% per year as of 2010, which was quite a while ago. But in 2017, global wind power capacity expanded 10% to 539 gigawatts. Yearly wind energy production grew 17%, reaching 4.4% of worldwide electric power usage, providing 11.6% of the electricity in the European Union. Denmark is the country with the highest percentage of wind power, with 43.4% of its consumed electricity being from wind turbines in 2017, which is impressive. We're getting close to half of the electricity it consumes is by wind. At least 83 other countries around the world are using wind power to supply their electric power grids. Prices have decreased over 80% since 1980 thanks to technological advancements and increased demand, so prices are expected to keep decreasing in the foreseeable future. And as prices decrease, it means that there's more demand for it, which means that we can just produce more or make more of it too, which is great. There are disadvantages, obviously. Wind is unpredictable. The availability of wind energy is not constant. As I said, wind is created by sun heating up, but you know as well as anybody, if you walk outside, it's not a consistent wind source every single day. It's not like you're always in a wind tunnel. Or you might be one day, it might be windy, one day it might not be. So that's something to consider. Wind energy is therefore not well suited as a base load energy source. If we had cost-effective ways of storing wind energy, the situation might be different. For residential wind systems, batteries are a common storage method, but in larger turbines, the batteries would have to be unreasonably large to be feasible. Both utility-scale wind farms and small residential wind turbines typically rely heavily on financial incentives. This is to give wind power a fair chance in the fierce competition against already well-established energy sources such as fossil fuels and coal. There's also the whole topic of birds that are hurt or killed by the turning vanes of a windmill that have been studied. There are a lot of results for or against this being true. But if we're looking at the big picture, wind turbines' impacts on birds and bats populations is pretty minor. Building windows, cars, and cats themselves actually top that list. However, because they still impact the bird and bat populations, it should still be considered, especially if there's room for improvement. Even if it killed half, right, or even a quarter or less than that, you still want to, try and get it as low as possible. If there's room for improvement, you should always seek for that. There are some ideas. So there's the option of installing bat deterrent systems. Basically, these bat deterrent systems are speakers that produce an ultrasonic signal similar to what the bats would use. So it creates essentially an area that's all muddled up, and it makes it difficult for the bats to navigate this area since it interferes with their own echolocation. For birds, there were studies in Norway done that found that just painting one of the wind turbine blades, if you painted it black, it actually just reduced bird deaths by 72%. Next one we're going to discuss is wave power generation. So the best thing about wave energy is that it will also never run out. Waves are a factor of the wind. They're created by the wind. So as long as we have the sun, then we have the heat to make the wind, which means we have the wind to make the waves. So waves aren't going anywhere either. There will always be waves crashing upon the shores of nations near the populated coastal regions. The waves flow back from the shore, but they always return. So also, unlike fossil fuels, creating power from waves creates no harmful byproducts such as gas, waste, and pollution. The energy from waves can be taken directly into electricity producing machinery and used to power generators and power plants nearby. In today's energy powered world, a source of clean energy is kind of hard to come by. So another benefit to using this energy is its nearness to places that can use it. Lots of big cities and harbors are next to the ocean, so they can harness the power of the waves for their use. If you actually were to look at like a population density thing, a map, it's staggering how much of the population of the world lives by water. Coastal cities tend to be very well populated as well, so lots of people could get use from wave energy plants. There are a variety of ways to harness it. Its final benefit is that there are a variety of ways to gather it. You have options. The current gathering methods range from installed power plants with hydro turbines to seafaring vessels equipped with massive structures that are laid into the sea to gather the wave energy. So the biggest advantages of wave power against most of the other alternative energy sources, it's that it's easily predictable and can be used to calculate the amount that it can produce. And the reason for that is because waves are consistent throughout the day and the night, thus electricity production is predictable and overall can be planned and properly managed. This makes wave energy more consistent than wind for sure, and also solar energy just because of cloudy days and then the different seasons. Once the wave energy converters, or WECs, are installed, the wave energy plant has low operational costs, which makes such an investment also attractive. Most of your cost is upfront, the actual installation of it. Wave energy converters are installed either on the surface of the water or they're submerged in the water, thus affecting the surroundings as little as possible. Many plants are built offshore, thus affecting the aesthetics even less. There's no danger of polluting the surrounding area in case of a disaster like there is with fossil fuel plants. Quite frequently, accidents at oil rigs pollute the surrounding areas. This can never be the case with wave energy plants, just like that BP oil spill we discussed last week. A positive side effect wave energy plants have is the fact that the capturing of the energy of the waves means that the power with which they hit the shoreline is less. If you're taking that energy from the wave, that wave has less now. It causes less damage and less corrosion of the shores. It acts kind of like a break wall. As I said, everything's got its pros, everything's got its disadvantage or its cons. So the cost is the number one disadvantage of wave energy, since the deployment of a wave energy plant and the installation of the wave energy converters involves installation of equipment in the sea and in most cases offshore, which takes the cost even higher. The cost of equipment used is high due to the fact that wave energy is relatively a new technology and a lot of research is still underway in this area to make it more efficient and less costly. Same kind of idea as how solar panels were much more expensive on the onset when they were first being developed versus how much less they cost now. These types of energy converters are installed in the sea and in many cases offshore, and thus they are exposed to strong ocean waves, storms, and certainly seawater itself. These are factors which may lead to their frequent breakdown, which results to loss of service, to production of which is a loss of production of electricity, a loss of income, and just an increase in operational costs. Saltwater itself, seawater, can be quite corroding in some instances to a lot of mechanical equipment. And there are a couple more disadvantages. Quite often, the wave energy plants are built in areas which are remote and far from the grid, in the same way from the need for electricity. This makes the connectivity to the grid expensive and difficult. They cannot just be built anywhere. They are built where there is sufficient wave power to justify the investment. In some areas where the installation of a wave energy plant is justified due to sufficient wave strength, there may not be sufficient funds to be invested, and vice versa. Maybe you have the investment, but you just don't have sufficient wave strength. Next one we're going to discuss is geothermal energy. So this is actually collecting energy from the earth itself. It's generally considered environmentally friendly. There are a few polluting aspects of harnessing geothermal energy. We'll discuss those in the disadvantages section, but these are minor compared to the pollution associated with conventional fuel sources, so again, your fossil fuels. The carbon footprint of a geothermal power plant is minimal. Further development of our geothermal resources is considered helpful in the fight against global warming. So geothermal reservoirs come from natural resources and are naturally replenished. Geothermal energy is therefore a renewable energy source. Sustainable is another label used for renewable sources of energy. In other words, geothermal energy is a resource that can sustain its own consumption rate. Unlike conventional energy sources such as coal and fossil fuels, you continuously need to feed more into it. According to scientists, the energy in our geothermal reservoirs, which is the core of our planet, will literally last billions of years. So, in a nutshell, even though I guess technically you would call it non-renewable if you really wanted to, because even billions of years in the grand scheme of things is still an end date, in terms of our existence, billions is a pretty safe bet. So as I said, it's a reliable source of energy. We can predict the power output of a geothermal power plant with remarkable accuracy because of that consistency. It's not the case with solar and wind, as I mentioned before, where weather plays a huge part in power production. Geothermal power plants are therefore excellent for meeting the baseload energy demand, something that wind cannot do. Geothermal power plants have a high capacity factor. Their actual power output is very close to total installed capacity. Another approach is to use the relatively small temperature difference between the surface and a ground source. The Earth is generally more resistant to seasonal temperature changes than the air. Consequently, the ground only a couple of meters below the surface can act as a heat sink or a source with a geothermal heat pump, much in the same way an electrical heat pump would work. So there are disadvantages. There always are, right? Earthquakes can be triggered due to hydraulic fracturing, which is an intrinsic part of developing enhanced geothermal systems or power plants. Many years back in January 1997, the construction of a geothermal power plant in Switzerland triggered an earthquake with a magnitude of 3.4 on the Richter scale. Commercial geothermal power projects are very expensive too. The exploration and the drilling of new reservoirs comes with a steep price tag, typically half the cost, and total costs usually end up somewhere between $2 and $7 million for a geothermal power plant with a capacity of 1 megawatt. For comparison, there's a power station in South Korea, which is a coal power plant that has a capacity for 6,446 megawatts. It's the second largest coal plant in the world, however, it still shows the staggering difference in capacity for a pretty large price tag. As you can see from the geothermal plant again on this picture, the general way it works is probably again, very familiar. The heat from the earth heats up the water, which creates steam, which causes the turbine to spin, which causes your generator to spin, which causes electricity, and there your electricity goes out. That heated water or steam slowly condenses back through a cooling tower, turns into cold water, and then injected back down into the earth where it heats up again and the cycle continues. Hydroelectric generation. So this is our dams. It is renewable, which probably surprises absolutely nobody here. It means it cannot be used up. However, there's only a limited number of suitable reservoirs where hydroelectric power plants can be built, and even less places where such projects are profitable. Unlike a solar power panel, which if you find a location where you can just toss one up, you just toss one up if you want to. You obviously need a location with a sizable river or a spot where you can build a reservoir to build your dam. Otherwise, you don't have anything to work with. So you are more limited. Generating electricity with hydro energy is not polluting itself. The only pollution occurs during the construction of these massive power plants, which again is due to the construction tools that we need to use, such as our trucks. Hydroelectricity is very reliable energy. The river is still going to flow. There are very little fluctuations in terms of electric power that is being output by the plants, unless a different output is desired. Countries that have large resources of hydropower use hydroelectricity as a base load energy source, meaning it's their base. As long as there are water in the reservoirs and electricity can be generated. So, the environmental consequences of hydropower are related to interventions in nature due to damming of water, changed water flow in the construction of roads and power lines. So the environmental consequences are not necessarily climate change related. They're more related to the biology of the world, of that area. So for instance, hydroelectric power plants may affect fish in complex interactions between numerous physical and biological factors. Fish habitats are shaped by physical factors such as water level, water velocity, and shelter opportunities, as well as access to food. Draining would be completely devastating to the fish. Beyond this, the amount of water may have different effects on the fish in a river depending on the type and stage of the life cycle. There are some fish that actually need moving rivers to attach their eggs to, rocks and stuff like that. You might completely dislocate a species by building this dam, and then they're not able to access a spawning ground or something. So building these dams can have impacts on fish populations, which can then impact, predators of these fish and so on and so forth, just like those food cycles or food chains show. It's all together. So far, we only utilize under 50% of our potential sites that would produce hydroelectricity. Canada's hydropower potential, more than double our current capacity, can help meet demand while reducing greenhouse gases and air pollutants. All regions of Canada have hydropower resources available for development, making it a truly national resource. And you can see here the technical potential and then our current installed capacity. So, for instance, even in Alberta, Quebec, Ontario, none of it, we're not even using any. There is quite a capacity for how much hydroelectric power we can generate, which is exciting. I love you. You can't, I'll show you this. Even PEI, it has a technical potential for 3, which, small number, but hey, it's something, right? We could use it. But as you can imagine, just based off the sheer size of these things and the scope of the work, building power plants in general for hydroelectric generation is pretty expensive. On the one hand, these plants don't require a lot of workers and maintenance costs are usually pretty low. Droughts, for obvious reasons, can really impact their production as well. We've already started using up suitable reservoirs, so there are currently about 30 major power plants that are expected to generate more than 2,000 megawatts under construction. Only one of these projects was started in the last 2 years. Okay, tidal generation. So we've already talked about geothermal, we've already talked about wind, we talked about solar, hydroelectric. All of these are based off of sun and earth for the most part, right? This one, tidal, as the name suggests with tidal, is based off the moon as that energy source. Remember what I said at the beginning, renewable is based off of one of 3 things. You're either going to get it from the sun, you're going to get it from the earth, or you're going to get it from the moon. So tidal power is early in the development stages. It's not able to compete with fossil fuels. However, focus on renewable energy sources and demand for clean energy contributes to a rapid development of methods to harness this energy source. So it's in the renewable energy portion of this presentation. So it probably doesn't surprise anybody for me to say that tidal energy is a renewable energy source. It's a result of the gravitational fields from both the sun and the moon combined with the Earth's rotation around its axes, resulting in high and low tides. It is this difference in potential energy that is the source of power generation from tidal energy, whether we're talking about stream generators, tidal barrages, or the more recent technology, dynamic tidal power. Dynamic tidal power projects have been installed in many countries utilizing tidal currents to produce electricity. So DTP is a very long, solid T-shaped dam built out perpendicularly to a shoreline amidst oscillating and hence accelerating tidal streams. This dam creates a pair of tidal waves on either side that together generate a hydraulic head pushing against the dam. You can see that in the picture here. This hydraulic pressure can be used to generate electricity by making openings in the solid dam and installing efficient bidirectional turbines. The total capacity of the dam turns out to grow exponentially with the dam length, a good reason to plan for very long dams. And when I'm talking very long, we're talking like in that first picture, like 20 to 100 kilometers long. So a big pro of it is that tidal currents are highly predictable. High and low tide develop with well-known cycles, making it easier to construct the system with the right dimensions since we already know what kind of powers the equipment will be exposed to. Because of this, even though the turbines that are being used are very similar to wind turbines, both the physical side and the installed capacity has entirely other limitations, and they're effective at low speeds. Water has 1,000 times higher density than air, which makes it possible to generate electricity at low speeds. Calculations show that power can be generated even at 1 meter per second, which is equivalent to a little over 3 feet per second. There are disadvantages though, of course, no surprise. They need to be constructed close to land. It's also an area where technological solutions are being worked on, however. Hopefully in a few years, we can exploit weaker tidal currents at locations further out in the sea. This is where dynamic tidal power may be utilized more in countries with smaller tides. It's important to realize that the methods for generating electricity from tidal energy is a relatively new technology. It's projected that tidal power will be commercially profitable within 2020 with better technology and larger scales. Biogas and biomass energy systems. These are one of the last ones we're going to be discussing. For these two methods, we have to recall talks about where the resource originates from. For example, burning wood does not add to greenhouse gases as it was a source already naturally developed and therefore does not add to the problem of greenhouse gases. Driving an electric car, using a coal generator, those don't help the environment on the other hand. All right, another video. Let me get me out of here.
Biofuels. Biofuels are combustible fuels created from biomass. The term biofuel is usually used to describe liquid fuels such as ethanol and biodiesel that are used as replacements for transportation fuels like gasoline, diesel, and jet fuel. Ethanol is an alcohol formed by fermentation. It is used as a replacement for or additive to gasoline. Biodiesel is an oil produced by extracting naturally occurring oils from plants and seeds. Biodiesel can be combusted in diesel engines or blended with diesel fuel. Biofuels are grouped in three categories based on the type of feedstock used to produce them. First-generation biofuels are produced from food crops. For ethanol, feedstocks include sugarcane, corn, maize, and others. For biodiesel, feedstocks are naturally occurring vegetable oils such as soybean and canola. Second-generation biofuels are produced from cellulosic material such as wood, grasses, and inedible parts of plants. This material is more difficult to break down through fermentation and therefore requires pre-treatment before it can be processed. Third-generation biofuels are produced using the lipid production from algae. In addition, the term advanced biofuels is used to describe the relatively new technological field of biofuel production that uses waste such as garbage, animal fats, and spent cooking oil to produce liquid fuels. Biofuels are currently the only viable replacement to petroleum transportation fuels because they can be used in existing combustion engines. This is an increasingly important advantage with growing concern about the environmental impacts of fossil fuels around the globe. Biofuels can also help provide energy security in regions that do not have hydrocarbon resources but do have suitable agricultural conditions. While there is some dispute over just how renewable biofuels are, it is generally accepted that the crops used to produce them can be replenished much faster than fossil fuels, which take millions of years to form. Concerns about biofuels are usually centered around the fact that they are an agricultural product. Producing these biofuel crops can mean competition with other natural resources, particularly land, food, and water. First-generation biofuels use only edible crops, which has led to biofuel crops displacing food sources in certain regions and subsequent spikes in food prices. In many regions of the world, subsidies are provided for these crops, which only amplifies these issues. In addition, increased agriculture of any form comes with concerns of deforestation and biodiversity loss, as well as water and fertilizer use, which have environmental and climate impacts all to their own. That's biofuels.
And that's biofuels. So biogas, on the other hand, is a renewable and clean source of energy like solar and wind power, which can help us reduce our reliance on fossil fuels such as coal, oil, and natural gas. Because these fossil fuels contribute to climate change, biogas actually reduces greenhouse gas emissions by preventing additional fossil fuel burning. It is therefore a great way to combat global climate change. Biodigesters do this by lowering methane emissions. Remember, I was saying methane is 20 times higher than regular old CO2, capturing the harmful gas and utilizing it as fuel instead of letting it dissipate into the atmosphere without use. Furthermore, the process of biodigestion is natural, not requiring any outside energy for the generation process, and the organic materials used in the production are renewable. Manure, food scraps, and crop residue are materials that will always be available, which makes biogas a highly sustainable option. So now I'll get into my weekly sponsor here with Home Biogas, which helps you generate free energy for your home using just your waste. Its second byproduct is rich organic natural fertilizer, which, for anybody who likes farming, there you go. This liquid digestive is a great alternative to chemical fertilizers because it can accelerate plant growth and resilience to diseases, whereas commercial fertilizers contain chemicals that have toxic effects and can cause food poisoning, among other things. They're usually pretty blank statements too, a lot of fertilizers, so they're not, they might be actually oversaturating your soil with certain chemicals if that's not what you're actually lacking. Impurities and corrosive gas mix. So after refinement and compression, biogas still contains impurities. If the generated biofuel was utilized to power automobiles, it can corrode the metal parts of the engine. This corrosion would lead to increased maintenance costs. This gaseous mix is much more suitable for kitchen stoves, water boilers, and lamps. And it also requires warm climates. Like other renewable energy sources, biogas generation is also affected by the temperature. The optimal temperature bacteria need to digest waste is around 37 degrees Celsius. In cold climates, biodigesters require heat energy to maintain a constant biogas supply. So biomass energy is the energy that is derived from organic matter of plants and animals. Biomass in the form of dead plants, trees, grass, leaves, crops, manure, garbage animals waste can be a great source of alternative fuels that can be used to replace fossil fuels. So plants make use of a process called photosynthesis that converts energy from the sun into chemical energy. We went over this in a previous presentation. This energy gets transferred to animals when they eat plants. When plants and animals' waste are burned, the carbon dioxide and the waste stored inside them is released back into the atmosphere, and then that can then be absorbed through photosynthesis again. This is why biomass energy is said to be renewable. It's perhaps one of the more controversial types of alternative energy that is being used. The principal positive of biomass energy is that it creates power by utilizing renewable assets. These assets may be wood waste, tree buildup, handled wood pellets, or urban waste. As a rule, biomass energy plants utilize leftover wood that comes from existing logging or sawmill ventures. By utilizing natural materials, there's less interest for power created by non-renewable resources like coal and gas. It can be used to produce methane gas, biodiesel, and other biofuels. It can also be used directly as heat or to generate electricity using a steam turbine. Again, probably sounds familiar. Consistently, we create huge amounts of solid waste. This waste involves biodegradable waste, recycling waste, along with dangerous toxic waste. Biomass energy uses this waste, so it's no longer sitting in a landfill. So we're providing a purpose for something that used to be just waste. And then there's some disadvantages. The biggest contention against biomass as a clean energy is the pollution that is created from burning the wood and other natural materials. Sometimes they're as bad as the pollution that comes from coal and other types of energy resources. There are a number of different compounds that come from burning biomass. Even though the energy is considered to be renewable, it's hard to claim it is a clean or efficient power energy when you're seeing these smokestacks being produced from them. And it can lead to deforestation. Wood is a major source of biomass energy. To produce considerable amount of power, large amounts of wood and other waste products have to be burned. The desire to produce energy on a large scale can lead to deforestation that would destroy the homes of a large number of plants and animals. And that kind of brings us towards the end here. So, as I said, all renewable resources and forms of energy come at a price. For the most, these methods of electrical generation help lower the environmental greenhouse gases because they prevent an alternative to fossil fuels and coal for power generation. There was a report by BBC that says that at present, China has 993 gigawatts of coal power capacity, but the approved new plants would increase this by 25%. China is right now the number one in world electricity production. This report states that 259 gigawatts of new capacity are under development in China. With the country's increase in manufacturing and overall increase in demand, there is a need for more electricity. Few options are looked at to using coal. Canada ranks number 6 in world production, but our biggest asset is that 60% of it is done with hydroelectric and only 9% coal. If you look back at the earlier slides where I showed you the breakdown of coal used in all the different countries. Canada is definitely really good at not using coal. I mean, we could get rid of the last 9%, but it's a pretty good target to have at the moment. With all the new technology advancing to better, more efficient methods for power, we still have a long way to curb the greenhouse gas issue globally. That brings me to the end here. I'm going to take myself off the screen so we can go through this whole thing. These are just some last minute checklist items for some housekeeping issues. So next week, we're going to be talking about climate change. There's a presentation on that. That's basically what the first point is there. Tonight at midnight, the Surviving Progress video quiz is due. If you miss it, you will not be able to complete it. So if you haven't done it already, please watch the video and then complete the quiz associated with it. On Friday, March 25th, the Green Technology assignment will be due on Friday, March 25th. And then on Friday, April 1st, this is we got the video assignment for Before the Flood, as well as essay assignment 2, which is on wildlife and climate change. They are both due on April 1st. And then after that, we got the One Ocean video assignment, which will be due on Friday, April the 15th. And then we got our final test on April 18th coming up around the corner. So this I'm going to be updating every week as we get closer and closer, but this just gives you in a nutshell what's due, when, and hopefully you guys use this as an aid if you need it. That's it for me. If you have any questions, any concerns or anything, please don't hesitate to reach out to me via email, or you can use the message boards on Blackboard. You can book a meeting with me if you'd like. All of that's available to you. Just feel free whenever you can. Yeah. Hope everybody has a great evening and talk to you next week.